Right, so we do see these things called master 1 and slave 1 and slave 2. So exactly what does master and slave mean in the context of this protocol standard? So what's important with digital communication protocols is a level of hierarchy. So exactly who is the one to talk and which one is the one to listen, and which one is to transfer data back whenever it's asked or requested to do so. So this is a reason why these are called masters and slaves. So these can be any sort of digital device in particular, but the master ultimately is the one that decides exactly what it's going to communicate to and exactly what kind of data it's going to be receiving. So the master pretty much has the control over this protocol. And the slaves, in particular, do their own thing and wait until the master requests data to be sent or requests things to be transferred to these particular slaves. So slaves can be any sort of digital device, and these are typically like sensors or something like that. So in the case with what we're going to be doing with I2C is we're going to be using a microcontroller as the master. So this is going to be the KL25Z or whatever ARM controller you're going to be using to just follow along this tutorial. And we're going to have one of these slaves be a color sensor. So the color sensor that we're going to be using is the TCS 34725. So this is a I2C enabled color sensor. It helps to detect different types of colors. It gets red, green, and blue values, and it also can detect the changes of the color. So it's actually pretty useful if you have something that changes color and you want to actually determine the actual color itself. So say you have like a color changing test strips or something like that, you can use this particular sensor. But I also skipped the aspect of the fact that you can actually see that there's slave 1 and slave 2. So what does that mean? Well, the idea about this is you also have to consider the idea of scalability when it comes to digital communication protocols. So the advantage of this I2C bus is that what you can do if you want to access multiple different devices, you can actually attach more I2C slaves to this particular protocol just by making sure that one wire is connected to the data line and the other one is connected to the clock line. So this in turn means you can actually have a near infinite amount of different slaves. So this makes it very, very versatile because you only need 2 digital pins to access 100 different types of slaves if you want to. But with that in mind comes the ultimate question of exactly how does a master determine whether or not it wants to select talk to slave 1 or slave 2 or slave 5 or how many different types of slave devices it is accessing or it has on the line in particular. Okay, so to allow the master to determine exactly which slave it wants to access, what each slave has is their own unique identification number. So this is typically when people describe it in spec sheet, it's called the slave address. So in this instance, maybe slave 1 might have the address of some sort of number of maybe 72, and slave 2 might have the address of maybe like 74. So the idea is that in the very first part of this protocol, it's going to go ahead and say I'm going to access the slave with an identification number of 72, and then the slave 1 is going to ping back and say yes, I got that information, and then the master will then transfer data or do whatever it needs to with that specific slave device. So with that in mind comes kind of an issue of I2C, where you can have a near infinite amount of slave devices on this line, but they have to but they all have to have their own unique identification number. If 2 devices on this bus or our I2C line have the same ID, what's going to happen is that they're both going to ping back and it's going to mess up the communication protocol. So that's just a small little thing to keep in mind when using this I2C digital communication protocol. And so with that, we're going to go ahead and delve a little bit on the actual protocols themselves in the next section.